Voyager's passage by Jupiter accelerated it towards a close encounter with the planet Saturn.
We can measure the data from these videotapes.
In the endless depths of space, humanity has dared to explore the mysteries that lie beyond our home planet. Voyager 1, our farthest-reaching emissary into the cosmic abyss, has been silently gliding through the darkness for more than 4 decades, and it has just come in contact with an unknown force in deep space. The spacecraft has been sending signals that have experts scratching their heads. It has stumbled upon a cosmic mystery that challenges everything we thought we knew about the void between the stars. But could these forces be from extraterrestrial beings out to destroy our home planet? Or could they be another intelligent civilization that we're simply just coming for the first time? So join us as we delve into the heart of this celestial mystery and uncover how Voyager has just come in contact with an unknown force in deep space, a force that could potentially spell the end for humankind. Background and mission of Voyager 1. Back in 1977, NASA did something groundbreaking that completely changed how we think about space. They sent out a super special spaceship called Voyager 1. The job of Voyager 1 was to explore and learn things about our solar system, especially the outer planets and their moons. It had a big mission. And you know what? Voyager 1 did awesome. It zoomed past planets like Saturn, Venus, Uranus, and Jupiter, doing even better than everyone hoped. Then guess what? It didn't stop. Voyager 1 kept going and going until it left our solar system. Voyager 1 just found something extremely unexpected after flying alone in space for over 4 decades. Scientists are all discussing it, and people everywhere are super curious. Now, before we reveal what they have found, it's essential to know this first. The significance of Voyager 1. Voyager 1 holds the record for being the farthest man-made object to ever leave Earth. As part of the Voyager program, its job was to check out the outer planets in our solar system. Equipped with fancy instruments and cameras, it snapped pics and collected data like no other space probe at that time. During this mission, Voyager 1 carries with it a golden record, kind of like a message in a bottle sent out into the universe. It's like a special space mixtape with sounds and pictures from Earth. There's thunder, Mozart's tunes, greetings in 55 languages, and even a map showing where we are in the galaxy. It's like a time capsule showing off our culture and knowledge. And get this, it's an invite for any aliens out there to come check us out. Now back to the recent news. Voyager 1 just picked up readings suggesting a brand new force in space. Imagine that. Everyone's talking about it, and in a moment, renowned physicist Michio Kaku is about to spill the beans on this mysterious force and the formula that might explain how the universe works. Exciting stuff, right? Voyager 1, the little space explorer, keeps surprising us. Voyager 1's trip through our space neighborhood has been super impressive. It didn't just cruise by Jupiter and Saturn, it did these awesome brief visits in a closer look, sending us super useful information about what these planets are like, from their atmospheres to their moons and magnetic fields. And it did capture some jaw-dropping pics. Imagine getting a front-row seat to see Jupiter's great red spot and Saturn's breathtaking rings. Those pictures still amaze and inspire us today. But here's the real kicker. Voyager 1 didn't call it a day after visiting the outer planets. Nope, it kept on going, bravely moving rapidly through the unknown space between stars. Interestingly, on August 25, 2012, Voyager 1 officially said goodbye to our sun's influence and stepped into interstellar space. It was like crossing a cosmic border. Now, it's not just an explorer of our solar system, it's a messenger from the great cosmos. And even though Voyager 1 is getting up there in years, it's still talking to us from a mind-blowing distance of over 14 billion miles. That's like sending a text message that takes more than 20 hours to reach your friend. It's crazy. But the coolest part? Voyager 1's instruments are still on a roll. Even in the vastness of interstellar space, it made a super cool discovery. The first sounds of the space between stars, it's like a space hum. And this was caused by charged particles doing their thing in the cosmic emptiness. These sounds teach us a bunch about what's out there beyond our solar system. What blows our minds even more? Voyager 1 was originally supposed to do its thing for just 5 years. But look at it go. It's like the Energizer Bunny of space, sending us pics and data long after anyone expected. Cheers to the genius engineers and scientists who made this space hero possible. Isn't it nice to delve into its composition? Components of Voyager 1. All right, diving into the nitty-gritty of Voyager 1's power setup, something called a radioisotope thermoelectric generator, or RTG for short. It's like the spacecraft's own power wizard. So inside this superb generator, there's a special ingredient, plutonium-238. It's not just lying around, scientists make it in special nuclear reactors. Imagine, they start with another isotope called neptunium-237, give it a bit of radiation, and voila, it transforms into the precious plutonium-238. It's like a cosmic alchemy experiment. Interestingly, the RTG has these things called thermocouples. They're like tiny energy dancers made of different materials. When the plutonium-238 does its slow dance of decay, it heats these thermocouples, creating a temperature dance party inside the spacecraft. This dance party is what makes the RTG generate electric current using something called the Seebeck effect. That current is like the lifeblood, flowing through Voyager 1 and powering up all its components and gadgets. When Voyager 1 started its epic journey, its RTG was a powerhouse, churning out a whopping 470 watts of electrical power. But, space is a tough place. As it ventured deeper into the cosmic unknown, the power slowly took a rapid fall. Plutonium-238 has this thing called a half-life, about 87.7 years. That means its power output gets cut in half every 87.7 years. Even after all these decades of extreme space conditions, Voyager 1's RTG is still perfectly working, putting out around 250 watts. It's like the little engine that could power through the vastness of space. Meanwhile, for every challenge, there exists a solution. So, this next finding will shed light on Voyager 1's monumental encounter with unknown force, the God equation, and other theories. Guess what? Voyager 1, our space superstar, recently had a bit of a cosmic encounter, and it's left scientists scratching their heads. The spacecraft sent back some weird messages, sparking a scientific mystery hunt that's like solving a galactic puzzle. Now, some intelligent individuals are thinking there might be a glitch in Voyager 1's system, prompting a completely developed investigation to figure out what's going on. It's like trying to solve a space-age mystery. But here's where it gets even more exciting. Scientists are diving into some out-of-this-world theories, and one of them is as captivating as a space adventure novel. It's called the God equation, and it's like the holy grail of physics. Imagine trying to find a single equation that wraps its cosmic arms around gravity, electromagnetic force, and nuclear forces. That's what these science wizards are after. A theory of everything. This God equation, cooked up by the genius mind of Michio Kaku, is like the superhero of mathematical equations, aiming to unite all the fundamental forces in the universe. Meanwhile, in a recent chat, Kaku tackled the mind-bending data from Voyager 1, raising questions about the possibility of running into an unknown force out there. As he's open to the idea, and it's got everyone wondering, could this mysterious force be the missing piece in uniting the grand theories of the universe? It's like a cosmic detective story, and Kaku's on the case. Meanwhile, diving into the fascinating world of science, where big brains like Michio Kaku are dreaming of something called the God equation. It's like the ultimate cosmic cheat code, a single formula that can spill the beans on everything happening in the universe. Imagine it as the magical spell that unravels all the secrets hidden in the cosmos. But why is this such a big deal? Well, science is like a giant puzzle with two main pieces: theoretical physics and quantum mechanics. Theoretical physics is like the boss level, dealing with the big stuff like planets, galaxies, and the forces that make them dance. Albert Einstein, the great genius, had laid down some serious rules with his theories of relativity in this arena. On the other side, you've got quantum mechanics, the cool rebel that lets us peek into the tiny subatomic world. Thanks to extraordinary technology, we can now study the tiniest particles, like quanta, quarks, and neutrinos, in particle accelerators like the one in Geneva. Imagine going from simple telescopes to these mind-blowing machines, a real leap in understanding the mysteries of the universe. Classical physics, the grandparent of the physics family, is all about what you can see, measure, and prove in experiments. Think about gravity. You can't see it, but drop an apple, and you'll get it. Newton rocked this field, defining forces and dynamics like a boss. But then comes Einstein, breaking into the subatomic party with theories about photons and quanta. He even bagged a Nobel Prize for this. Not his famous theory of relativity as many think. But here's the plot twist. Einstein knew his discoveries were like puzzle pieces missing the full picture of the cosmos. He spent his life hunting for the ultimate cheat code, the unified field theory, a single formula that could sum up everything in one scientific mic drop. That's the dream Michio Kaku and his pals are still chasing, the God equation that spills all the cosmic tea in one elegant sweep. Einstein, facing the mystery of quantum physics, boldly rejected its principles, famously declaring, "God does not play dice." He grappled with the probabilistic nature dominating the subatomic realm, a stark contrast to his physicist worldview. Born in 1947, Michio Kaku, during his academic journey, encountered quantum theories and realized they weren't incompatible with traditional physics. To his surprise, Kaku found that the two branches of physics were not mutually exclusive. This revelation reshaped his understanding of the universe. Kaku, acknowledging the practical applications of physics, highlighted the profound impact each force discovery had on human history. From Newton's mechanics and gravity sparking the Industrial Revolution to Maxwell and Faraday unifying electricity and magnetism, ushering in the Electric Revolution, the course of humanity has been shaped by these breakthroughs. Einstein's iconic equation, E is equal to mc squared, unlocked the secrets of the nuclear force, further illustrating the transformative power of physics. Despite these advances, a formidable challenge looms: the reconciliation of two fundamental pillars of modern physics, relativity and quantum theory. Einstein's general relativity, describing gravity through smooth space-time curves, clashes with quantum theory's discrete particle interactions. This disparity complicates the quest for a unified theory, a challenge that has confounded brilliant minds throughout history. Kaku, specializing in string theory, proposes a unique perspective. String theory envisions particles not as point-like entities, but as tiny, vibrating strings, akin to the strings of a guitar. These strings, vibrating at different frequencies, give rise to the diverse subatomic particles observed in nature. String theory's beauty lies in its symmetries, allowing the interconversion of particles. Electrons can transform into neutrinos or neutrinos into quarks. Kaku, firmly standing behind this theory, believes it is the only mathematically consistent contender in the quest for a unified understanding of the universe. While alternative theories often stumble upon mathematical inconsistencies, diminishing their credibility, the allure of string theory lies in its unwavering internal coherence. It stands as a beacon of hope in the pursuit of the theory of everything, seamlessly weaving the fabric of the universe into a comprehensible narrative. Yet, string theory faces intimidating evaluations, chiefly the scarcity of experimental tests, challenging its validity. Despite this, Michio Kaku radiates hopefulness, envisioning a future where technological leaps and refined scientific comprehension propel us toward the litmus test for string theory's assertions. Delving into the implications of a grand, unifying theory sparks wonder. The prospect of time travel, the existence of traversable wormholes linking distant cosmic realms, revelations about events preceding the Big Bang, and the notion of parallel universes within a vast multiverse tease the curious mind. But before exploring how the God equation might aid in resolving Voyager 1's potential malfunction, a historical interlude unfolds. In 1980, Voyager 1 wrestled with a significant challenge linked to its gyroscope, a pivotal component ensuring the spacecraft's stability. The gyroscope's anomalies, detected then, stirred concerns among mission operators and engineers, jeopardizing Voyager 1's precise path. This finding about the unknown force will send a shock down your spine. Unknown force detected. A dedicated team of scientists and engineers embarked on a meticulous journey, analyzing telemetry data, conducting simulations, and unraveling the intricacies of the gyroscopes to steer Voyager 1 back on its celestial course. This historical episode sets the stage for understanding the intricate dance between technology, problem-solving, and the vast cosmic expanse. After thorough investigations into the gyrations of Voyager 1's gyroscope, the culprit was unmasked as the wear and tear of aging components and the unforgiving space environment. In response to this cosmic weariness, the brave team engineered creative solutions. Software updates, similar to cosmic patches, were deployed to offset the gyroscope's diminishing accuracy. The attitude control system, the spacecraft's celestial compass, underwent a recalibration, ensuring it stayed true to its destined path. These innovative interventions successfully stabilized Voyager 1, allowing it to soldier on in its mission, unraveling the mysteries of the outer solar system. Journey to the heliosphere. The seemingly outdated technological relic from the 1970s, Voyager 1, now enters the cosmic stage to illuminate the connection to the elusive God equation. In 2012, Voyager 1 etched its name in history as the inaugural human-made entity to breach the confines of our solar system. Beyond this celestial boundary, a distinct cosmic theater unfolds. The interstellar medium, the vast expanse between stars. The heliosphere, a grand bubble emanating from our sun, becomes a backdrop to this cosmic drama. The essence of the matter lies in the particles' density within these cosmic realms. Inside the heliosphere, a bustling neighborhood with approximately 100 particles per cubic centimeter contrasts sharply with the sparser expanse of interstellar space, where the density dwindles to a solitary particle per cubic centimeter. This stark variance perplexed researchers and sparked a contentious debate. As Voyager 1 ventured into this interstellar realm, the falling rapid particle density raised questions about the transmission of sound in space. Would sound, relying on particle oscillations, become an interstellar mystery lost in the cosmic vacuum? However, the cosmic saga of Voyager 1 takes an unexpected turn as it ventures into the interstellar medium, defying our preconceptions. Instead of the anticipated thinning and instability, Voyager 1 unveils a denser and more resilient boundary, challenging the initial predictions. A similar revelation transpires during Voyager 2's boundary crossing, as researchers brace themselves for an expansion of the heliosphere due to robust solar winds. To their surprise, Voyager 2 mirrors the data transmitted by its predecessor, reshaping our understanding of the intricate dance between the interstellar medium and the heliosphere. Despite the passage of years, Voyager 1 remains an unwavering cosmic explorer, hurtling through space at an astounding speed of nearly 37,000 meters per hour. Astonishingly, It continues to dutifully relay data back to Earth, with a time lag of several hours. Dedicated antennas, strategically positioned for this cosmic dialogue, capture these transmissions. But with old age, Voyager probes may suffer more anomalies. Voyager 1. Inconsistency. However, the mystery deepens as Voyager 1, in 2022, reports data anomalies that initially trigger concerns of technical malfunctions. However, the data stabilizes, leaving scientists contemplating the possibility of age-related malfunctions or the influence of an enigmatic cosmic force. This conundrum births the Voyager Inconsistency, a celestial puzzle unfolding amidst staggering distances. Voyager 1's signals, racing at the speed of light, require over 22 hours to reach Earth, introducing substantial delays in transmitting instructions or commands. The spacecraft, operating on instructions dispatched from Earth in the distant past, finds itself out of sync with the present state of affairs on our planet. This temporal misalignment creates a fascinating scenario where Voyager 1 executes commands that, when observed in real time from its current location, appear outdated. Commands from a bygone era lingering in the vast cosmic expanse. The Voyager Inconsistency unrolls a fabric of compelling questions that delve into the intricacies of communication across cosmic distances and challenge our temporal perception of events in the vast expanse of space. It serves as a cosmic riddle, urging us to contemplate the monumental time scales and mind-bending distances inherent in interstellar exploration. In navigating these celestial quandaries, renowned physicist Michio Kaku offers prudent counsel, advocating for meticulous scientific scrutiny to validate any newfound cosmic forces encountered by Voyager 1. Could this enigmatic force be the hard-to-catch piece completing the cosmic puzzle? Might it unlock profound insights into the realms of cosmology and creation? These captivating questions remain open, beckoning us toward further exploration to unravel the cosmic mysteries. In the pursuit of understanding the God equation, humanity stands on the brink of not just comprehending creation, but also wielding the power to actively shape it. The potential implications of such understanding are both simple and extraordinary, promising a deeper connection with the cosmos and a transformative impact on the very fabric of existence. What are your thoughts about this unexpected discovery by Voyager 1? Let us know your answers in the comments below. See you in the next video.